Hello and welcome back. My name is Dan Oak and I'm a student at Athabasca University, and I'm currently taking the course Computer Science 444 Embedded/Robotic Programming. And if you've been watching any of the videos I've posted on the Comp 444 forum so far, first of all, you're an extremely patient person because my videos leave a lot to be desired. I'm definitely not a content creator. But hopefully you've at least learned a little bit about the nRF24L01 RF transceiver module. Basically, it's a module that allows you to add some, wireless communication to your Arduino projects or your microcontroller projects. It basically allows you to set up 2 or more microcontrollers and with 2 or more of these modules and have wireless communication between them. So as you can see here, this quick overview, there's a couple different variations of the module. Ranging from ones that are very compact with an internal antenna to ones with an external antenna and kind of a hybrid in between, and with the internal antenna. Basically, the main difference is the range. So the very tiny compact one here has a range theoretically of about 100 meters. That may be different in real world conditions, but spec sheets are 100 meters. Up to this version here, which has a range of approximately 1,000 meters or 1 kilometer. And as you move up into these 2 modules, you have some power amplification and some signal noise reduction. So it just helps make a little more of an optimal signal when transmitting. Again, if you've been following, I've shown that you can get lots of information online about these modules and how to use them, but the best tutorials I've found so far are by How To Mechatronics, that has a video, as well as the website where you can get all of the schematics and code associated with the video, as well as the main tutorial I've been going through is one by Autodesk Constructables, which again has a video and all of the schematics and pictures and images and code that you want. There is another video I did reference earlier in the other videos that deviates a little bit from the other 2 tutorials. So the other 2 tutorials by How To Mechatronics and Autodesk Constructables are very similar in their structure and the examples that they show, whereas this one deviates a little bit and has some different code that from the nRF24 library than the other ones do. So if you're interested, you can look up this tutorial by Ralph S. Bacon, named as such. And if you have been following along, you'll notice that we've been going through the tutorial by Autodesk Constructables, and I've just been I've basically highlighted some of the important parts that I think are a little more pertinent, and just been going through it with you. So in the last example, we've been doing a lot of examples. We've had examples where we've had this guy. So we've had 2 Arduino Nanos hooked up. One was acting as the transmitter and one was acting as the receiver. Both of them were hooked up to the compact internal antenna version of the nRF24L01 module. This one is just hooked up through a socket adapter, which just basically allows for a little more neatness. Normally, maybe not the way I'm using it here, but I basically just did that just to show that there is a socket out there for it. But really, at the end of the day, the main thing I showed you with this was we transmitted the text "Hello World" from the transmitter module to the receiver, as well as I also showed you how to use a joystick on this end, on the transceiver, to control a servo motor on this one. But we did that early on in one of our examples. Then we moved on to an example where we showed how to do button presses to control LEDs, and I can show that one right now by I won't hook up the Arduinos to the computer or anything like that. We'll just hook it up to this power supply. So now both Arduinos are hooked up to an external power supply, and again, if you press the red button on the Arduino that's set up as the transmitter, it will cause the red LED on the receiver to light up. And if we press the blue button on the Arduino and nRF24L01 module set up as the transmitter, it will cause the blue LED to light up on the receiver end. And in this example, I'll unplug both these. We were using the external antenna version for the nRF24L01 modules. So again, this just will extend the range. Instead of having a 100-meter range theoretically, you can have a kilometer. So we've done that. But that was in our previous examples. So in this example, I've got a couple other breadboards with things hooked up. So this is the Arduino kit red board by SparkFun Electronics. This is the board that came with the COM44 kit. I've ended up purchasing the other boards through Amazon for one and AliExpress for the others, just so that I had a bunch of boards and stuff to play with. Plus Arduino seems pretty fun, so might as well buy some stuff. It's all fairly inexpensive, depending on how much you... I mean, obviously, if you buy as many as I'm buying here, you're going to get a little pricey, but... yeah, so that's pretty much it. So let's get to the code. So, again, the point of this example, by the way, I should just mention that you'll notice that I'm going to set both of these up as transmitters and receivers. So each module, each nRF24L01 module, which I'm using external antennas modules for this one as well, each one of these is going to be set up as a transmitter and receiver. So not at the same time. We're going to write in the code so that sometimes it's transmitting and sometimes it's receiving. So what does that mean? Well, that means that sometimes when I use the push buttons, it'll be in transmit mode and it'll transmit the signal to the this Arduino hooked up with this nRF24L01 module, and we'll control the LEDs. So it'll be acting. This will be acting as a transmitter with the buttons, and the LEDs will be over here, and it'll be this module will be acting as a receiver. And then at the same time, well, not actually at the same time, but for all intents and purposes, the same time as far as we're concerned, but in the code we'll be switching between them. We're going to be able to move the joystick on this side, and it's going to act as the transmitter. So the module will be acting as the transmitter when I'm controlling the joystick, and then it's going to go over to this Arduino, or the red board rather, and through the module, and it's going to control the servo. So both boards, so this board is going to be acting as a transmitter some of the times when I'm dealing with the buttons, and a receiver to move the servo, and sometimes this is going to be acting as the receiver when the LEDs are being controlled, and the transmitter when moving the joystick. So we'll see how all that works. And again, that's all in the tutorial by Autodesk Constructables. So this is the one we just did, where we just had two LEDs, a receiver end at the receiver end, and two push button switches at the transmitter end, and we were sending the button presses to the receiver end. And now we're at this point where code 3 was our example where we have the same node, i.e. the same nRF24L01 module. That's what we're calling the node here. We're having the same node act as the transmitter and the receiver. So bidirectional communication. And then we have the other one acting as the receiver and transmitter as well. So again, in the third example, we're going to show that a single node can act as both a transmitter and a receiver. Just remember, you can't send and receive data at the same time. So for all intents and purposes, it's going to seem simultaneous to us because of how fast code is able to execute. But in all actuality in the code, we're going to have to stop listening and start listening at different times. So we're going to have to call stop listening when we want the code to act as a transmitter, when we want the module, the RF transmitter to act as a module, a transmitter rather. And when we want it to act as a receiver, we're going to have to call the start listening function. So we're going to be toggling between those. So that's going to toggle between sending and receiving data. When it's acting as a transmitter, again, we're going to be using the stop listening function to turn the node into a transmitter and then send the data with radio.write. And then when we want it acting as a receiver, we're going to use the radio.start listening function to read the incoming data. And then assuming that we're going to use radio.available to see that there is data to be read, and we're going to use radio.read function to get that data. So that's pretty much all that says. So now let's get to the code and we'll go through it. So this is the code that's going to refer, so the code on the left here, because in this case they're both acting as transmitters and receivers. So it's not like before where I had on the left the transmitter code and on the right the receiver code. No, in this case they're both transmitting and receiving. So the code on the left here, in the left Arduino IDE, corresponds to the red board. So the setup I have on the left. And the code I have on the right here is going to correspond to the Elegoo board, the Uno here. So with that being said, let's look at the code and compare as we normally do. So on the transmitter side, we're including one extra library. So we've been including these three libraries with all of our code. So we've been including the SPI library, a library specific to the module itself, so the nRF24L01 library, and the RF24 library. So that we've been including the whole time. Again, you can either download the RF24 libraries and nRF24 library through GitHub, or you can use the library manager and just search and download there. I've already got it installed, but by TMR, you can do it that way. We're also including the servo library here because, as we've shown on our red board setup, we do have a servo motor, so we need to include that library. And then we've got a couple defines here. So we've got a couple constants for our buttons, button 1 and button 2, which are on pins 3 and 4 respectively. So we can see that we've got two buttons hooked up. And again, you can kind of tell, I've kind of got the colors of the wires backwards here. Seems I have a blue wire for the red button and a red wire for the blue button. A little odd, but you can see the buttons are going over here to, looks like digital pins 3 and 4. I don't know if you can see that very well. Pins 3 and 4. So there you go. So that's what we've got going on that code. Again, the only other library we've included that we haven't in the other ones is the servo library, and we've got a couple defines for a button. And then as usual, we're declaring an instance of RF24 called radio, and we pass in two arguments representing the chip enable pin and the CSN, the chip select not pin, associated with the RF transceiver module. Again, I've hard-coded those in. I could have made defines or constants representing the CE pin and the CSN pin. That might be a little more explicit, but again, I'm just following the tutorial for the most part. The big difference here, and then actually before I talk about that, I'll go to the receiver side. So we've included the same libraries. We've always included the SPI library because the module uses SPI communication, and then the two libraries associated with the module itself. I've also got a couple defines here for pin 5 and 6 LED. I have this one commented out. I guess at one point I had, instead of a define, I had a constant representing LED pin 2. Either one's fine. This is kind of like an older school version associated with kind of like the C style, which Arduino is based off C and C++. So that's kind of old style, but it still works in both C and C++. Kind of the new way to do it would be use const in front of your just an int variable. The difference is this one doesn't have an assignment operator or a semicolon, and this one you have to assign, like all variables, and terminate your expression with a semicolon. So either or is fine. I'll just comment this out because we seem to be using the defines over here. And then as usual, again, we've declared an instance of type nRF24 called radio, and we pass into arguments into the parameterized constructor representing the CE pin and the CSN pin. So now here's the part where it's a little different than the code we've had before, where we've had each module set up as either a transmitter, a dedicated transmitter, and the other module set up as a dedicated receiver. But in this case, where we have both them set up that we're going to be transmitting and receiving with the same module, we need to include two addresses. So instead of having a single one-dimensional array of type byte, we're having a two-dimensional array of type bytes so that we can have multiple addresses. So again, we've declared them as const because we're not going to be changing these. These are addresses that we're not going to be changing the whole time. The address is how they're going to communicate with each other. So again, it's just you just have to make it a two-dimensional array for your addresses as opposed to one, and obviously have two addresses associated with that. And that's for both sides. For the left setup, we're declaring an instance of type servo, so servo called myServo, and we're declaring a couple booleans associated with what's going to represent the button state for our two buttons. So, and I'm defaulting them to 0 for each of them, and that's again representing the state they're going to be in. And then one other thing we're doing a little different with this one is we're going to send the data as a package. So that way I can send both button states all at once instead of just doing a bunch of different separate write statements. I'm going to create a structure called data package, as you can see here. So we're creating a struct data package, and in the struct we have two properties in there. So boolean for button level 1, default set to 0, and a boolean for button level 2. So our package contains both these values. So remember, a single write statement, if you've been following the videos, a single write statement will allow you to send 32 bits of data. So in this particular case, I'm only sending 2 bools worth. So that's bools like a byte each. So I'm only sending 2 bytes of data. But I could send more. I could have like more variables and stuff and send it all at once. So that's what we're doing here. And for anyone who's not familiar with, who's got into Arduino but isn't fully familiar with what a struct is, or is not as well versed in C or C++, a struct, if you're familiar with object-oriented programming, a struct is kind of like a class, but it's just a very small, watered-down class. So where a class typically has data attributes associated with it and functions, so methods. So basically it has, data and properties, things ways you can manipulate the data. A struct typically doesn't have functions or methods, so it doesn't have behaviors, it just has state. So that's what this is. So it's kind of just a very small sort of class. And then so this is the definition of our struct called data package, and then we actually declare an instance of data package. Don't initialize it, but we declare it. So data package that we call data. So we're creating a variable with the above structure. And again, the whole point of this code that we're creating here is so that we can send all the info as a single data package. And again, we could include more info here, up to 32 bits. What we do, we also have to, because we're sending this whole data package, we have to create the exact same structure in the other setup. So in our create the exact same structure for the code that's going to go on our Uno over here. In the setup for the breadboard setup on the left, we're going to start off with our serial.begin, get everything going at 9600 baud rate. We're going to have our pin modes for set up our buttons as inputs. We're going to attach our servo to pin A5. So our servo is connected to pin A5, so the signal wire A is connected to pin, sorry I have that on the screen, A5. Probably hard to see there, but A5. So we've done that. So this is all just setting up our serial monitor, which we're going to use a little bit, our buttons, and our servo motor. And then the rest of the code is as we've kind of seen before. It all deals with the nRF24L01 modules. So we call the begin function just to set up everything. And in this case, normally when we had the transmitter, we call the open writing pipe method on the transmitter, and on the receiver end, we would call the open reading pipe. In this case, both modules, the left and right setup, are going to be acting as a transceiver and receiver and a transceiver and receiver. So this is going to be both transmitting and receiving data, and this is going to be transmitting and receiving data. So because of that, we have to open up both pipes for writing and reading on the same module. So again, we're going to call the radio.open writing pipe, passing in address sub 0. We have to indicate the index of our multidimensional array this time. So we're going to grab address sub 0, which is going to be this one, for our writing pipe. And then on the receiving end, we're going to go radio.open reading pipe, passing in 1. Remember before we could pass in 1 or 0. So passing in 1 for our first argument, and then address sub 0, which again refers to 0001. On the other end. So again, the address that we pass into the writing pipe of one of the modules is the address that is going to be for the reading pipe of the other module, and then vice versa. So when we go radio.open reading pipe on this one, which is now address sub 1 referring to the 0002 address, that's going to be in the writing pipe of the other module. So again, the big takeaway here is the address for the writing pipe of one of the modules is the address for the reading pipe of the other, and the address for the reading pipe of the first module is the address for the writing pipe of the second. And then we're going to set the PA level as normal, so radio dot set the power amplification level, just passing in a constant. We've been up to this point using the constant RF24_PA_min because again our communication is going across a few inches on a desk. But in this case, I've put max. I think that's what the tutorial had. And here, again, we could put min. We're, inches away, our modules. But again, the whole point of using the power amplification, if you make it max, it's going to draw more power for the module from the, the microcontroller or an external power source, whatever is powering the module. But it's going to allow for better transmission, allow you to, reach those theoretical limits, like 100 meters or 1,000 meters, depending on if you're using the internal or external antennas. So that's what that does. Now finally, moving on to the loop. The loop of the left setup, again, the left setup is your red board that has your push buttons and your servo motor, whereas the right setup has the joystick and the LEDs. The loop for the red board setup with the buttons and the servo motor is as follows. We're going to have a delay of 5 milliseconds and then radio.start listening. So we're going to start off by being in receive mode. So radio.start listening. Now if radio.available, we're going to go into this code. While radio.available, we're going to keep reading. If there's data to be that's being transmitted to us, we're going to keep reading it. We're going to declare a variable of type int called angle v and initially set to 0. And then we're going to use the radio.read function to read in some data that's being transmitted to us. We're going to store the value we read in into angle v, the variable we created, because again, we're being passed by reference, hence the ampersand. And the second argument is always the size of the data we're expecting. So we're going to read whatever was transmitted to us, we're going to read it into angle v, our variable, and then we're going to use that variable to write to the servo. So my servo.write, we're going to use the write function to write to that angle v, i.e. moving the servo to that angle, which will be somewhere between 0 and 180 degrees. 0 and 180. And then we're going to also just print that value to the serial monitor just so we can see it. So this is just redundant just so that we can visualize it. And then we're going to delay by 15 milliseconds again. That's just to allow the servo time to physically move to position. So we're not we're not transmitting the data faster than we can physically move the servo. And then we end that while loop and end the if statement. And then we have a delay of 5 microseconds just to give us some time. And then we're going to stop listening. So again, this code is all associated with receiving. We're setting up the left setup that has the red board. We're setting this up as a receiver first. and we're basically reading in an angle value that we're going to use to move the servo. And then we go radio.stop listening. We take the same module and we now stop listening because we're going to set up as a transmitter. And so we're going to do a digital read of both buttons that are set up. So again, remember, we have 2 buttons along with the servo. So we're going to do a digital read of both buttons, see if they're high or low. And then we're going to set the variables, the instance variables associated with our data structure. Remember, we created a data structure up here that had 2 variables of type bool, button level 1 and button level 2. We're going to set those by going data.buttonlevel1 equals button state 1 and data.button level 2 equals button state 2. Basically, it equals the state of what we just read off of the pins. Low if they aren't pressed and high if they are. And why is that the case? Well, because I've got resistors, pull down resistors. I don't know if you can see that very well. It's a lot of light. Let's shut that off. So we have pull down resistors going to ground, meaning the buttons won't have floating states. They'll be held low when they're not pressed, and they'll go high when they're pressed. So either way, whatever state the buttons are in based off the digital read, we're going to assign that directly to the variables associated with the data structure. And we can assign these directly because by default, structs, the values in structs are public, which that's another difference between classes and structs. Structs members are private by default, so, and that's typically what you want for the data associated with a class. So the variables you want to be private, but then you typically make the interface of the class, things you need, the way you need to interact with the class, i.e. the methods and functions, getters and setters and all that stuff, you want to make them public. But a struct, because it's meant to be kind of a very simple class, it's really just, you know, a way to contain a bunch of different variables that are similar in some way. By default, everything is public. So meaning we can directly access them by just going data, which is the name of our data structure, and then dot notation, and then the name of the variables, button level 1 and button level 2. So again, go into a little bit of the weeds just to verify how familiar people are with the various coding structures. And then finally, once we've read the state of the buttons through the digital read function, we've assigned them to the data structure, we're going to write that data structure and transmit it. So we're going to use the radio.write function, and we're going to send a reference to the data structure, hence the ampersand. So we're sending a reference of it, and the size of the full data structure, in this case the 2 booleans. So we're sending that. So again, just to be clear, first we're receiving, and what we're receiving is the angle that we're going to move the servo motor to, and then we're transmitting the states of the buttons. On the receiver end, first we are listening. So first we're transmitting. So if we're first receiving on this side, well, that means we're first transmitting on this side, where they have to be opposite. So we delay 5 microseconds, then we radio.stop listening, which means we're transmitting. And what we're going to do is we're going to do an analog read of pin A0 to get some pot value. So again, on this side, we have an analog joystick, which is acting as a potentiometer. It's hooked up to A0, so the signal pin associated with, so we've got the ground pin is black in this case, the 5 volt pin is white, so that's connected to our power and ground, or 5 volts in our ground, and then the gray signal pin is connected to VRX. So obviously I could have hooked up other pins here. The joystick allows for X-axis movement and Y-axis movement, as well as this final pin is for a switch. You can actually push down the joystick and there's a button in there. In this case, I'm only using it for the X-axis movement. I'm essentially using it as a kind of a just to control that servo motor on the X-axis. So I've got that signal wire hooked into A0. So yeah, where was I there? So we're doing an analog read off A0, assigning that to the pot value, and then because that value that we're going to read on an analog pin is going to give us a value between 0 and 1023, because again there's a 1024 bit resolution, 2 to the 10th bit resolution. we're going to have to take that value and then map it from 0 to 180, because that's the range of the servo motor that we're controlling. And we will assign that to angle value. And then that's when we write and transmit the value. So radio.write, we're going to write that angle that we just got, which is going to be somewhere between 0 and 180 based on our joystick. And we're going to send that to the red board, which is on the left here, which is in receive mode. So again, we're going to write that there. Then we're going to delay 5 seconds, 5 microseconds, 5 milliseconds. Okay, so we're going to delay 5 milliseconds, and then we're going to go radio.start listening. So this is where we were transmitting. Basically, we were stop listening, so we were in transmit mode. We did an analog read of A0 to get a pot value. We mapped that pot value, which was going to be between 0 and 1023. We mapped it to a value between 0 and 180, and then we wrote that and transmitted that over to the other setup, which was in receive mode. Then now we're going to be in receive mode. So now we're going to go radio.start listening, put us in receive mode, and while there's no radio.available, not radio.available, we're just going to wait there. So basically radio.available is going to return true or false, whether or not there's data being transmitted to us. And so if it returns false, meaning there's no data being transmitted, well, not false is true. So we're just going to hang out this infinite loop. This semicolon just represents an infinite loop. We're just going to stay in this line of code until there's some data being transmitted to us. As soon as there is data transmitted to us, we're going to go beyond this loop, and we're going to read that data in. So radio.read, read that data in, and store it in data, which is the struct, the data package structure that we created earlier. Once we have that, we're going to end up, basically, we're going to have values for button level 1 and button level 2 that we've read in. So we're going to find out what we have. We're going to use an if-else structure, a couple if-else structures, to determine what the state of the buttons was. So if data.button level 1 equals high, meaning if the button 1 was pressed on this module, we're going to do something on this module. What are we going to do? If it equals high, we're going to use the digital write function to make LED 1 high, whatever the buttons correspond to. So if the blue button is pressed, the blue LED is going to be on, and if the red button is pressed, the red LED is going to be on. And then we're also I'm just printing to the serial monitor what's happening, LED 1 on. That's just, again, redundancy. Else, I'm going to put the LED low, so it's going to be off, and I'm writing that to the serial monitor. And then I'm doing the same thing for button 2, checking if it's high. Again, you don't have to explicitly check if it's high. I think they do that in the tutorial, which is why I did it. But you can just go because basically it's returning a Boolean anyway, true or false, high or low. So we don't have to go if data dot button level 1 equals high. We can just go if data button dot 1. This will be high or low, true or false. So this is just redundant to do this. So we could just do this. So again, if this one's high, we're going to turn LED 2 pin high, and we're going to write it on the serial monitor. I think I just put some spacing here just so I could see the differences. They're going really quick on the serial monitor. And yeah, if it wasn't pressed, we're going to keep it low. That's pretty much the code for the two things. So let's see it in action first. Let's plug in one of these. Okay, so I plug that one in. And we're going to upload the sketch. So again, this is the sketch associated with the push buttons and the servo motor. And then we're going to hook up this side. I'm just uploading that code now. Okay, we get the serial monitors going for both of these. Actually, I'm not sure if we were even writing to the serial monitor in this case, so this might not show anything. But this one should. So again, it's going really quick, so it's not that much use to us. And this one I think is just showing the angle. What am I writing here? Let's see. Oh yeah, I'm just printing on this side. The only thing I'm printing is the angle of that I'm going to write the servo motor to. So right now it's at 89, is exactly in the middle because the joystick is not being pressed. But let's actually look here. We won't worry about the serial monitor for a minute. We'll just look here. If they're both, again, this one is acting as both a transmitter and receiver, and this one is acting as transmitter and receiver. So if I press the button, this one will be acting as the transmitter, and this will be the receiver, and the corresponding color LED light will light up. So if I press the blue LED lights up, although not very much. Let me just shut off this light. Seems a little dim, but it lights up, and the red LED lights up if I press the red. If I press both, they both light up. If I let go, they both shut off. So blue, red. That is a little dull. I'm not sure why that is. So I don't know if you can tell. And I'm not sure why. But this blue LED doesn't seem to... It is lighting when I press, but it's not very bright. Whereas the red is really bright. And there's no reason for that, so I'll have to take a look at that in a second. Perhaps I overlooked something. But the other thing is, if I use the joystick, I can control by just along the x-axis, I control the servo motor. So back to center, all the way this way, back to center, all the way this way. So you can see, and again, both of them can be acting as a transmitter and receiver at the same time. So by holding down this button, this side is acting as the transmitter, and that side is acting as the receiver, but by using the joystick, the side with the joystick is acting as the transmitter, and the servo motor that's moving is the receiver. So both are acting that way. Let's just take a quick look and figure out why that blue LED is not lighting. And you can see, before I do that, you can see that the joystick, I'm moving the joystick, it controls the serial monitor here. So, and on this side, if I press the blue LED, you can see LED 2 on, LED 1 off. If I press LED 2, it's off now because I let go. If I press the red LED, LED 1 on. And if I press both, they're both on. That's really not that useful for us. So I'm just going to shut those off. Okay, so why is our blue LED not lighting up? Let's take a look. Okay, here's the issue right here. I've done the pin mode, so I declared both pins. LED pin 1 is pin 5 and LED pin 2 is pin 6. But down here I did pin mode. I apparently just did pin mode for one of them. So we'll do pin mode for this one. LED 2 pin. Set it up as an output. So I guess with the Arduino, it could be set up as an input by default. Maybe the internal resistor, there's a 20 kilo ohm resistor associated with the digital pins of the Arduinos. Maybe that was on by default in a previous code that I used. So therefore, when I pressed the button, it was acting as it was still outputting, but it had that internal resistor on, like 20 kilo ohms, which would make the thing pretty dim. So let's try re-uploading and see if we can get it brighter. So before it was uploaded, that's how bright it was, not very bright. And now we're uploading. Uploading now, done uploading. Let's see if we got any brighter. Yeah, so huge difference. So again, that's a lot brighter than it was before. And red. So no difference in functionality, just you know, a little brighter. So yeah, that was, I just again, in case anyone was not paying attention there for a minute, as I am droning on, I forgot to include pin mode for LED pin 2. But that's essentially the code for the two of them. Just to again show you that this, I always do this, show you that it's not running through the computer and in fact is wireless. I'm going to unhook the USB from the computer, hook it into a power bank. So this is just hooked into a power bank. I'll unhook the other one. So I'll unhook this joystick, hook it into a power bank. I just got a separate power bank here. So now these are both hooked into power banks. And as you can see, the functionality is still there. If I press the blue button, blue LED lights up. Red button, the red LED lights up. And the joystick controls that. And there's some little bit of delay there, but that's from the code, and that's pretty much that. And so these are completely wireless, not tethered to anything. Well, besides a power bank right now. But you could have also hooked this up through the barrel plug with a battery. In fact, I'll do that just to show you. So here's the battery pack that came with the SparkFun Inventors Kit that came with our course. So again, through the battery, it'll work as well. So, yeah, no strings on these guys. And that's pretty much that. So, again, if you've listened this far, thanks. I'm just posting these as requirements for the course, just so I can show what we've done. But if you do watch the tutorials, you don't have to necessarily watch these ones. I am pretty long-winded, I understand that. But if you just read through the tutorials, I'll also post some stuff. My versions of the tutorials, which are basically the tutorial, just I've highlighted some things. And I've summarized some stuff. So for example, I've taken this, all the stuff associated with this tutorial, and I've just kind of summarized it in this form, kind of like with the main pertinent information. So if you want that, I'll post that as well. But beyond that, appreciate you guys watching. These are fun little things to do. Again, it just means that you can, be controlling your Arduinos from across the room from each other, or really a kilometer away if you have these external antennas. So thank you very much, and have a great day.